And coronavirus family is a large family of viruses there were 6 different coronaviruses. First one was detected as early as 1957. The 6th one was detected in 2002, and this one is the 7th virus detected in Wuhan. And this virus is known as corona for the reason that from the Latin word, corona means crown. So like the British or European monarchy's crown, this virus is also having spikes which are looking like crown. So that's the reason why they derived the name corona. And you can see this electron microscopic pictures of the virus which is showing the corona. And this corona is not a single shape or single size, it's pleomorphic. So what is pleomorphic? So pleomorphism is shown in potatoes. Potatoes are never of the same size or same shape. They are in different mix of different size and shape. And they look under microscope, under electron microscope, something like concorda, the vegetable which we eat. And average spherical particle diameter is 120 nanometers, whereas an oval or oblong virion is having a maximum diameter of 160 nanometer and a minimum diameter of about 60 nanometer. And there are 2 kinds of spike on the surface of this corona. One is known as entry spike, which is made up of glycoprotein. Now remember this glycoprotein, this is not a simple protein, this is a glycosylated protein. So that means that protein has a covering of the sugar, and that's the reason why it affects the diabetics much faster than the others. So this is a glycoprotein having about 12 nanometer length. It's very fluffy, like सूतरफेणी या दोस्त बुढ़ी के बाल जो बोलते हैं हम, उसके जैसा है, थोड़ा लंबा होता है, but it's very fragile and very fluffy. And the other spike is HE spike, that is heme agglutinin esterase spike. So these short spikes are for the exostosis, that is for exiting out from the cell once they have replicated in number, and the entry spike is for taking entry into the cell. And its genetic material is very remarkable. It is a single strand RNA. It is a positive phase single strand RNA. That means it's a messenger RNA straight away. So human cell doesn't have to replicate first from negative RNA to create positive RNA and then positive RNA to mRNA. So it's a messenger RNA straight away. So as soon as it infects, it starts its work, because he has the material, everything ready to induce the production factory of cell to produce. And it's such a big genome, very few viruses have such a large genome, 29,980, so it's almost 30,000 bytes. So there are 30,000 nucleotides. That means the 30,000 nucleotides have an instruction to the cell to produce 9,860 different amino acids. Now you imagine that the entire human life, our body does not produce more than 20 amino acids. The entire humanity lives on 20 amino acids. There's only one 21st amino acid which is produced only when you are exposed to atomic radiation. That is seen only in the population of Hiroshima and Nagasaki a few years ago. Now even that is gone. So instead of 20 amino acids, this guy is asking our cells to produce almost 10,000 amino acids. And this is the reason why it causes such a big cytokine storm. It causes such a chemical locha, such a big chemical locha in our blood system, that the inflammatory system, humoral as well as systemic, goes haywire. And it is not playing. So as I said, this is the glycoprotein, and this is the HE, hematylin and agglutinin. This is the protein and fat made capsule. that is known as capsid, and this is the genome, which is a single genome of 30,000. And the virus is so tiny that as many as about 72 lakhs viruses can fit in one swollen reticulocyte or one swollen white blood cells. And they have an affinity to infect red blood cells also. And how small is this virus now?
We'll have to reshare, sir.
I will. I'll pause it and then reshare it.
And just so you know, 7:30 is the time.
Yeah. Right. So this is how. It's a good 3D animation so that we know how the virus enters. Now, there is on the goblet cell of the throat mucosa, there is a receptor which is known as angiotensin converting enzyme 2 receptor, which believes that this is the enzyme, not the virus. So it immediately hooks it up and takes it into the cell. So this is endocytosis. And once inside the cell, the virus starts giving its instruction to the ribosomes. It takes over the Golgi apparatus completely and forms its own replications. And when it forms about 1,80,000 replications, the cell is so much swollen up that that cell will die, and these guys, they will come out. So now, how small is this virus? Now, it takes more than 70 abaj viruses to make one patient ill. That is 10 times the world's human population. And there are about 40 lakh infected persons in the world so far, and one virus weight is 0.85 attogram. So the total weight of viruses of all these patients, all these 40 lakh patients, if done together, it is only 2 grams. And then this very nice paper came up on 8th of April, which measures how long a virus from a casual contact would survive on different environmental conditions and different surfaces. And it was found that on paper and tissue it survives only for 3 hours, on cloth for 24 hours, but on surgical mask it stays for 7 days, and on paper money it stays for 4 days. Now, why this happened? Why this variable timing? This we'll discuss when we discuss on maskology, because it's very important to understand. And as I said, maskology itself is a science in itself. I never knew that maskology is a different field of science and you can do a diploma in maskology.